Hey everybody, Dawson here, and today we are going to look at using Pythagorean theorem. And so we're actually going to be trying to use this as best we can. We've been doing a lot of work with it lately, and I want to dive right into it and try to use it a little bit more than what we have been doing, and trying to get it to actually do some work for us. So we're going to pick two dots, and we're going to get this in class tomorrow too. You're going to pick two dots, and we want to find the distance between the two dots. Distance between the two dots. So if I do that, then I make a little line between these two, here to here. I want to find the length of that line. And so the length of that line, you're like, oh right, if you find the area of the square off of that line, we can figure out, take the square root of that, and get the length of this line, no problem. But sometimes these lines, or we want to get to the point where we can do it without having to find the area of the square off of this side, because it could be a little awkward, it can be a little difficult with all these strange angled squares, and you could do it, but it's a lot of work. So we want to start using the information that we got yesterday to help us to find the area. So let's make ourselves a right triangle, and this is really where Pythagorean theorem comes in. It's all about right triangles. Remember, right triangles are triangles with a 90-degree angle in it. You cannot use the Pythagorean theorem if it doesn't have a right angle in it. So we got to make sure we have a 90-degree angle here. Well, if we look at the side lengths, we got a side length of 2 here, and then a side length of 1, 2, 3 on this side. And we want to find the area of the squares that are off of this side. So if this side length's 3 and this side length's 3, well, that's going to be an area of 9. And this one's a 2 by 2. So this side length, or this area over here, is going to be 4. And we have 9, area of 9, and area of 4. And one of the things that we learned from our activities we were doing just before this one was that the area of this square is the same as the area of this square, the area of the hypotenuse. Let's use Captain Vocabulary's vocabulary. The area of the hypotenuse square is the same as the area of leg 1 square plus the area of leg 2 square. And so I know that if this is 4 and this is 9, that the area of this is going to be 9 plus 4, or 13. And so if I know that this is 13, then I know that the length of this line will be the square root of this area, or the length between those two dots is going to be the square root of 13. Not a perfect square, and so I have two options. I can leave it as square root of 13, or I can estimate it at 3.7, 3.6, 3.9, whatever. But that's going to be an estimate of that. I could, in this case, because these are centimeter dots here, I could put in centimeters if I wanted to as a length. But for this one, you could just say 3.7 units or something like that. That'd be fine too. Okay, so let's kind of refresh what we have to do here in order to solve this problem. Step 1 is to connect the dots, and we will be doing this in class tomorrow. Connect the dots. Okay, that will make the hypotenuse of a triangle. Connect the dots. This line will become the hypotenuse of your right triangle. Okay, so then step 2 is going to be to make the right triangle. And then step 3, find the areas of the leg squares. Step 4, we're going to add those two areas together to make our hypotenuse square area. add areas of leg squares to get hypotenuse area. And the final step, step 5, is to take the square root of the hypotenuse area. There you go. So that's those are all the steps involved in going from just having two dots, wanting to find the distance between those two dots, and finding that distance. We did all that work. Connect the two dots with a line, create a right triangle off of that line. So we have a three-sided triangle here with a right angle between the two legs. Find the area of the squares off the legs, add those together. That's the area of the square off the hypotenuse. Take the square root, and we get our distance between those two lines. So that's it. I'm going to give you one more example. Okay, and what I will say is to go ahead and make a dot, and then go over 4 spaces. So 1, 2, 3, 4, and then up 1. I'm going to go over 4 and up 1, and that's going to be your problem. So go ahead and pause the video and find the distance, the length between these two dots on this grid. Okay, when you're done, go ahead and turn it back on. Okay, let's see how you did. First thing I talked about is you have to connect the dots. So we're going to put these two together. Remember, this is called the hypotenuse. This will be the hypotenuse of your triangle. And then you'll make your right triangle. Come down there, come up there. We're going to have 2 triangles off the sides here. And so we want to make a little triangle here. This is a little small, but that's okay. And we went down 3 on this side because we went over 1, 2, 3, 4. We're going to go to 1, 2, 3, 4 as well. We're going to do the same thing for both of those. So we have our 2 squares here. The area of this one is 1. The area of this one is 1, 2, 3, 4 by 1, 2, 3, 4. So that's 16. 4 times 4. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can just count them up too. So 16 on this one, 1 on this one. It means the area of the square off of this side is going to be 17. Once we have the area off these two sides, we know that the length between those two dots is going to be the square root of 17, or approximately 4.1 or 4.2 or something like that. All right. For your homework, make one more of those dots. Just connect any 2 dots and you find the area given the same strategy we used, and then you are all done. All right, and before we go, I want to make sure you get your joke. So, what is a mathematician's favorite dessert? Pumpkin pie. Pi, 3.14, pi, circles. Yeah. All right. Anyways, have a good one. See ya later.